Hello, my name is Manupriya Sadashivam, and this is my project 2 of IE464 Virtual Automation. In this project, I have used Cosmo Worlds and MATLAB to form a simulink model of a water tank system. Here we can see three input values coming from the sliders. Here I've used a subsystem to calculate the height of the water level in the tank. I've also used the subsystem over here to display the lights by comparing the desired value of the water with the actual height of the water level. Apart from that, I have animated the water inflow and the water outflow. I've also used the subsystem over here to show the movement of bottles on the conveyor belt using a repeating sequence. The values have been recorded using graphs such as multi-plot graph and XY graph. Now we look at the 3D animation of this model. As you can see, this is the plant layout of the water tank system. So there's a tank that's supplying water to the main tank under study. There's the inlet pipe, there's the inlet valve, and this part of the inlet pipe is kept transparent so as to show the water flowing into the main tank. There's the outlet pipe, there's the outlet valve, and this part of the pipe is kept transparent so as to show the water flowing out of the main tank and into the bottles. The bottles are kept on the conveyor belt and are moved onto them. The forklift transfers the materials from the conveyor belt onto the truck, and the truck then carries it forward from there. Here is a light system displaying the red, yellow, and green light, which is decided by comparing the desired value with the actual height of the water level. There are three control systems over here with sliders on them called the set point, outflow, and tank area. So the initial value of the set point is 0. This implies that the desired value is lower than the actual height of the cylinder, and hence the red light is switched on. Now if we play this further, we can see that as the set point value keeps increasing, we'll see that the water level will go on increasing once it rises above the actual height. We'll be monitoring these graphs later. So we increase the value of the desired set point, and once it exceeds the actual value, the green light gets switched on because now the desired value is greater than the actual value, and the water level in the tank starts increasing. Now when the tank is completely full, this implies that the desired value is equal to the actual value, and that's why the yellow light comes on. Now for the outflow pipe, we decrease the desired value of water in the tank and increase or open the outflow valve, and you can see that the water level in the tank starts decreasing till it reaches the desired value set by us. The tank area, that's the third valve that we are using, monitors the area of the tank. So if the tank area increases, the rate of water level rising or falling in the tank reduces accordingly. We can see this by increasing the tank area to a maximum limit. Now if we set the desired value to a 0, we can see that the water level in the tank decreases, but at a much slower rate than before. This is because the area of the tank has increased. We can see behind in the animation that the forklift had carried the bottles onto the truck, and now the truck will transport them to another workplace area. You can see that the water level in the tank does not oscillate because the PID has been controlled. We can also check out the multi-plot graph, which shows the desired value of the water that has been set by us. Thank you.